Talk about this question from 2006, question 3 from 2006, and let's try to solve all these three part C, part D, and part E in this one video. We are dealing with question 3 from exam 2006. Now we're looking at C, D, and E. For C, calculate the lowest frequency of light that could release a photoelectron. It asks about the threshold frequency here. So for C, we write F0 is going to be phi work function over H. So it is given here. So it should be very easy to do. So what we have to do is to have some taps on the calculator. 2.58 times 10 to the power of what? Negative 19. Negative 19 over 6.63 times 10 to the power of negative 34. And it's going to be 3.89. 3.89 times 10 to the power 14 hertz. Now this is the lowest frequency of light that can trigger this photoelectric effect. Part D, explain the effect on the number and the energy of electrons released when the frequency of light is decreased. The effect on the number and the energy. So we know that frequency, now EK is electrons released, right? Yeah, energy of the electrons released. The energy is actually the kinetic energy, and it is maximum kinetic energy of electrons. It is going to be HF minus phi. Now, phi is a constant, H is a constant. Now, if we lower frequency, then the energy of electrons becomes smaller too, right? Yeah. And explain the effect on the number of electrons released. The number of electrons released should remain the same. Why is that? Because we know that the number of electrons is related with intensity of light. The intensity of light. Now we just decrease the frequency. We haven't changed the intensity, so the number of electrons should remain the same. So the number of electrons remains the same. We haven't answered this one, right? Then energy electrons. Okay, so the energy of electrons has decreased. Okay, so this is part D, and for E, I think it has a different it has kind of different preconditions here. The photocathode is replaced with a different material when illuminated with the light of a wavelength this much. Electrons with the maximum kinetic energy of this much are produced. Calculate the threshold frequency for that material. So I guess we have to erase, or maybe we don't have to erase it. Let's try it. This is part E, the threshold frequency of that material. Still, we use this F0. F0 is phi over h. And now remember, we are dealing with another kind of material, so phi is different from the previous one. Now we still use this EK is equal to HF minus phi. So we have phi is equal to HF minus EK. EK is given. F is not given, but wavelength is given. Wavelength is given means frequency is given. So F is going to be C over lambda, and we have EK. No. We have F0 is equal to HC over lambda minus EK over H. So it is going to be C over lambda minus EK over H. So we plug in all the numbers here. C is 3 times 10 to the power of 8. Lambda is given 2.8 times 10 to the power of negative 7 minus EK 3.04 times 10 to the power of negative 19, and Planck's constant 6.63 times 10 to the power of negative 34. It is going to be equal to, let's use our calculator here, 3. Wait, can we use the previous? Yeah, sure. Now this time we only have to change something here. Wait. Come back here. Wait, what is the negative 19, huh? Negative 19 this time. .04 and we only have to change this. Remember, it's 2.8. Am I right? Okay, great. Wait, what? Do I have to do it again? Exit. It's like 3 times 10 to the power of 8 over 2.8 times 10 to the power of negative 7 minus 3.04 times 10 to the power of, what is it, 19. Negative 19 over 6.663 times 10 to the power of, so it's going to be 6.13. 6.13 times 10 to the power of 14 Hertz. Now this is a new threshold frequency.